Hello everyone. Okay, so this section is section 1.7. Yeah, I think it's 1.7. Okay, so again, before I start the section, I just want to remind you guys about the first exam. So first exam is coming next week, not this week. It's next week, which is going to be on September 10, and the exam is going to be during our regular class time. All right. I mentioned this on the first announcement. Also, the announcement you can see in the blackboard. All right. So I said that the exam is going to be. I think also I've said that in the introduction video as well. The exam is going to be during the regular class time, and you know the schedule. All right. You know the schedule. If you still don't know where you find the schedule, well, again, I have showed that in the showed you guys that in the introduction video. I can show you one more time. If you go to this course, if you go to information, and there's a schedule here, tentative schedule. So, so you know exactly when the exam is going to be. All right. So this is okay. I'm doing 1.7. So yeah, it's next Thursday. All right. So the exams are going to cover everything till this point, till section 2.1, 2.2. This one, I will include this 2.3 and 2.4 on exam 2. But exam 1 is going to be till here. Okay, so it's pretty much everything from chapter 1. And then from chapter 2, it's going to be section 2.1 and 2.2. Okay. And okay, about the timing, the exam. Okay, like I said, the exam is gonna start. Okay, you are going to see your exam. I'll talk more about the exam timing and everything, but in brief, I'm planning. So our regular class time is 5:30 to 6:50, right? So yeah, I'll give you guys this whole class time plus 25 minutes extra to scan your work. So so adding this whole thing, I mean, 25 minutes scan is your scan time, but it's up to you how you want to use these time. You can your full time you'll get is 1 hour 45 minutes. All right. So it's up to you whether you want to use, let's say, 1 hour 40 minutes to do your exam and 5 minutes to scan and work. However, you want to do it, I'll give you 1 hour 45 minutes. So within that time, you have to submit your work. All right. If you don't submit your work within this time, you won't be able to submit your work. So that means you will automatically get 0. So be very careful about the time and make sure your internet is working good. All right. And just to be in the safe side, well, obviously you have to upload your work in the Blackboard. So I have already made the tab here. Oops. I've already made a tab here, the exams. Well, I don't think you guys can see it now, but yeah, once I upload the exam, I will create you'll see this tab, and once you click here, you will see the exam 1 tab. So you can just upload your work there just like you did in the quiz. But once you pass that 1 hour 45 minutes time, so basically, so if you start from 5:30, means 6:31 hours. So May 6:30, 7:15. So your I think the due time will be 7:15. So if you don't submit it by 7:50 p.m., if you don't submit your work exam by 7:15 p.m., then you won't be able to submit your work. To be in the safe side, you can email me your work before this time. Even if you email your work after this time, I am not going to accept your work. Just be clear on that. So this is exam, all right? This is exam. So exam has to be within certain amount of time. And if you take extra time, it's not going to be exam anymore. If you get, so I have to be fair with everyone. So yeah, like I said, to be in the safe side, you can still email me your work before this time, if you have any technical issue with the Blackboard. All right, just be clear on this. Anyway, let's start. Let's start section 1.7. Okay, so this section is actually about the precise definition of limits. So previous section, I think section 1.6, I talked about the limit, right? And the limit, we were taking the limit from the graph and stuff like that. We did that, right? Now, now in this section, we are actually going to see the definition of limit, and using the definition of limit, we'll be proving the limit. I'll talk more about that later on, but okay, so here, the limit here, okay, so here, okay, let's say, okay, let's just make a random graph here. Okay. Okay, let's pick a point here. Let's say on x-axis, this is A, and on y-axis, here we'll get L. Okay, let's make this graph. Let's make this graph like this. Just give me a moment. Something like that, okay? All right, so here, what it is saying, and this is f of x graph, okay? So with this limit, it is saying that as x approaches to A, then this f of x on y-axis approaches to L. That's the L value, right? Now, now using the precise definition of limit, the limit says that, okay, now here the limit, the definition of limit, the actual definition of the limit says that, okay, here we are going to work with epsilon, epsilon delta. I see most of the students get confused on this epsilon delta. What is epsilon? What is delta? Blah, blah, blah. You know, it's confusing. I know even when I was taking this class, it was confusing to me as well. So I can understand why this is confusing. But I'll try my best to make it simple. All right. I'll try my best to make it simple. Okay. So here, the limit definition says that for every epsilon greater than 0. So epsilon is something, some constant that is greater than 0. All right. So when you talk epsilon, we can think that the epsilon is going to lie on on y-axis. So there is epsilon that is greater than 0. Let me write the whole thing, and I think it's easy to explain from that. Then if there is epsilon, for every epsilon greater than there is a number delta greater than 0. All right, so for every epsilon greater than 0, there is another number, another constant greater than 0, such that now if x minus a is less than delta, and this is greater than 0. Okay, so now what it is saying that is, like I said here, x is approaching towards a. There is x that is approaching towards a, but it is not exactly a. It is just approaching towards a. All right, that's what the limit means. Some value is approaching towards some point. All right, so let's make an interval. All right, let's make an interval. So within this interval, there is x that is approaching towards a. All right, so this is interval. So that now here, this point is a point, right? So here, this point I can say now this value and this value are exactly, the length of this is exactly the same. So that length is going to be delta. All right, so you can think that delta is going to be on x-axis, epsilon is going to be on y-axis. All right, so and this delta, this distance for this interval, so from this point to this point, it's delta. Similarly, from this point to this point, it is also delta. So that means here, this point I can say a minus delta point, and this point I can say a plus delta point, right? Because this is delta, so this point a plus delta is going to be a plus delta, and here it is on the left hand side, so this one is a, and if we subtract this delta, then we're going to get a minus delta. All right, so here, that means if there is any x between this interval, then there must be f of x minus L, which is less than epsilon. So now the epsilon is going to be an x, so there is going to be another interval. So again, this from L to here, this is epsilon. From this point to this is also epsilon. So that means here, this point, from this L point to this one, this is L plus epsilon, right? And from this point to this one, it is L minus epsilon. Okay, so that means this f of x is approaching towards L, right? F of x minus must be less than epsilon. All right. That's what the definition of the limit is. And if you understand this definition, and if you take some high-level math course later on, I don't know, maybe advanced calculus or something like that. If you understand this definition, your life is going to be much simpler. Well, your life is going to be so easy if you really understand this definition. All right. It's just that the epsilon is going to be on y-axis, delta is going to be on x-axis, so that on x-axis, the x minus a, x is really close to a, that's what it's saying, x is approaching towards a, right? X is really close to a, and the difference between that is going to be delta, which is really small. And if we have that on y-axis, we will be getting same thing. F of x is going to be approaching towards L, and the difference between that, the distance between that is again really small, which is epsilon. So this epsilon value and this delta value are really small value. All right. So this is the actual definition of limit, or we can say precise definition of limit. Okay. Okay, let's do this then. Next page. Let me use different color. Okay, let's say this is 5, this is 3, and now we can say that here using this, you can say that, okay, this is a value, this is L, or simply we can write limit of x goes to a, or x goes to 5 of this function is, let's say, f of x, x is equals to 3, right? Now let's do this then. Let's prove this one. Okay, so here this limit is given, and so if you see x goes to 4, 4 times 2 is 8, 8 plus 3 is 11. This is obvious, right? But we need to prove this. All right, we need to prove this using precise definition of limit, which means this definition I just stopped here. I need to use this delta epsilon. All right, we need to use delta epsilon. So this is very important for the exam. So please watch it very carefully, all right? Because I am going to ask this in the exam for sure. Something similar in the exam for sure. All right, so this is very important. All right, so there is a way of doing this. So if you understand the way, it will be very simple, all right? So first, to prove this thing, I need to, okay, so as we know that from this definition, we need to show now, yeah, it says that, yeah, we need to show this. If this is this, then I need to prove this. Let me write that here again. So we need to show, okay, this is a rough work, all right? Or let's just say scratch work. But you need to show this scratch work as well, all right? Why? I'll explain that later. But you still need to show the scratch work. This is not actual proof. We are proving some of this, and we need to prove this, but before that, I need to show the scratch work. So let's write, need to show here, if x minus a is less than delta, then absolute value of f of x minus L is less than epsilon. All right, so basically we need to prove from here to here. That should be our actual proof. Okay, now, but here, what we want to do here is from here to here, yeah, like I said, I need to prove from here to here, but what we need actually is the value of delta, which we don't know the value of delta. So to get the value of delta, there is a way of getting the value of delta. Okay, but before we do that, we can see that we can compare this equation to limit of x goes to a of f of x is equals to L, right? That's what I have here, right? So this means this thing. This is the definition of this means this, right? Okay, so here comparing this to this, I know that the A is 4. This whole thing is f of x, and this is L, right? So from here, if absolute value of x minus a is 4 less than delta, if we have this, then we need to prove that f of x is 2x plus 3 minus 11. L is 11, right? 11 is less than epsilon. Okay, so what we need to do here is, like I said, I need to prove from this to this. But in the scratch work, I need to go from here to here to get the value of to get the equation of delta. Okay, so how do we do that is from here, let's work on this. Okay, so from there, what we can say from there is 2x plus 3 minus 11 is minus 8 is less than epsilon. All right, and then here I can factor out 2, so 2x minus 4 is less than epsilon. All right, so this 2 is a number, so I can, in algebra, I can basically just take that 2 out, because the absolute value 2 is still 2, and absolute value of x minus 4, absolute value is less than epsilon. Now divide both sides by 2. So the absolute value of x minus 4 is less than epsilon over 2. All right, now I got this from this, I got this, right? Now when I see this, when I compare these two, there is x minus 4, there is x minus 4, there is absolute value less than, there is, we have delta, here we have epsilon over 2. So what we can do here is delta, that means delta, we can assume delta as epsilon over 2. Okay? So one thing you need to understand in the scratch work is, scratch work goes from here to here, or basically from absolute value of f of x minus L less than epsilon to x minus a less than delta, to get the value of, to get the equation of delta. So I got the equation of delta, which will be epsilon over 2. That's only for this, I'm doing this whole thing. All right, but you guys still need to show me this scratch work. All right, you have to show me this scratch work. If you don't show me your scratch work, you will lose points. All right, now after this, our real proof starts. So the real proof is basically, now I got this from here to here. Now it's just that in the real proof, you have to go the opposite direction from here to here. Okay, so the actual proof, okay, let me write proof. Okay, so the proof will start from let delta is equal to epsilon over 2, or epsilon over 2, because we found delta value from scratch work. Now our actual proof is just strictly going to start from there. All right, now if I said here, our actual proof is going to go from here to here, right? So now taking this equation, x minus a is less than delta. This implies that, this is imply sign. So this implies that x minus a is 4, right? 4 is less than delta, I said epsilon over 2. Okay. So basically I'm proving this thing from this point, right? Now multiply 2 on both sides, so I'll get 2 x minus 4 is less than delta. All right, now mathematically, or in algebra, we can just we can just put this in, 2 inside this absolute value, which will get 2 times x minus 4. Basically, we're just going opposite direction. Like I said, this is just the opposite direction of whatever we did here. Here I get 2x minus 8 is less than epsilon. And here I need to change this 2x minus. I have to do that. All right, since we are proving it, I have to show that part as well. So our actual, our final answer, or we have to change this to this form, 2x plus 3 minus 11. So I can say that, right? So 8 or negative 8 is also 2x plus 3 minus 11 is less than epsilon. So from here, 2x minus 3 is f of x. This is L. So that's what we are trying to prove, right? That's what I said. I have to get this from this, right? So that's what exactly I'm getting from this. I can say that finally it's f of x minus L is less than epsilon. All right, so that means if you get this from this using all of this, so the main thing here is getting the delta. So once you get the delta, start from here, get this, show me all these work. Maybe in the exam I'll ask a different problem, but the way of getting should be exactly the same. All right, this is how you need to show your work. And getting this, to get this, you have to show your scratch work. And scratch work doesn't mean like, okay, you said x plus 2 here, let's say x plus 2 here, and is equals to, let's say, 3 here, 5 here. That's not how scratch work should be, at least on this one. It has to be in a systematic order, all right, like I did here, so that I can understand what exactly you're trying to do. Okay, so it has to make sense when I read your answer. All right. Okay, so this is the way of proving using the definition of limit, or using the precise definition of limit. All right, let me do a few other problems as well. Okay, let's do this one. Now here we have a quadratic function. All right, so again, so start from scratch work. Oops, the scratch spelling is not correct. Scratch work, right? So again, let me just write that. Basically, we are trying to prove that if x minus a is less than delta, then from this point, we need to prove f of x minus L is less than epsilon, right? That's what actual proof should be, right? This should be our actual proof. But here in scratch work, we are going from this to this to get the value of, to get the equation of delta, right? So now let's start from here. So from this, we can say that f of x is this whole thing, right? That's f of x, x squared minus 4x plus 5 is f of x. This is a, and this is L. All right, so now start from here. So starting from here, f of x is x squared minus 4x plus 5 minus L is 1. 1 is less than epsilon. All right. Now from here, x squared minus 4x plus 4 is less than epsilon. So factor this. So x squared minus 4x. So there is 4. So 4 times 1, that's 4. 2 times 2, that's 4. So I can use 2 and 2 because I have negative 4 in the middle. So using 2 and 2, I can say x minus 2. X minus 2 is less than epsilon, right? This is algebra. Okay, now, okay, x minus 2, I can also say x minus 2 square less than epsilon, right? Now, take square root on both sides. So this will get x minus 2, absolute value of x minus 2 is less than square root of e. Okay, now, basically we are getting from this point to this point, and here we have if x minus 2 is less than delta, right? So when you compare this, now on left hand side we have x minus 2, we have less than. So that means the delta, in this case, our delta is going to be absolute value of epsilon. Sorry, square root of epsilon. Right, delta is square root of epsilon. All right, so that's what the scratch work is for. It's getting this, right? So now once we get this, so again, like I said, the scratch work should be clear like this. It's, or basically it has to be in a systematic order that I can see where exactly, what exactly you're doing to get the value of delta. All right, so after this, now our actual proof is going to start from here, right? Now the actual proof is going to go from here to here. So if absolute value of x minus a is less than delta, then this implies that absolute value of x minus a is 2. Yeah, 2 is less than delta value. Like I said, first I have to assume delta as square root of e, right? That's what I got it from there. So now square root of epsilon. Okay, now after this, basically we're just going opposite way. So now let's just take the square on both sides. So x minus 2 square is less than epsilon. All right, so I have to change this to f of absolute value of f of x minus l, right? So now I know that this is x minus 2 square is, or basically a plus b whole square is a square plus 2ab plus b square. That's formula, right? Or if you have a minus b whole square means a square minus 2ab plus b square. So in our case, a is x and b is 2. There's a minus, so that means I'm going to use the second formula. So x square means a square is x square minus 2ab means 2 times x times 2 is 4x plus b square is 4. 2 square is 4 minus epsilon. All right, now here we are actually trying to get this, right? Because here we have f of x. Basically, we're trying to change or trying to get this from this point. So I have to get f of x minus L. So the way we get f of x minus L is now x squared minus 4x plus 4. I can also say plus 4 is plus 5 minus 1 less than epsilon, right? So that way this thing is f of x. There is a minus, right? Minus, and this is L. Okay, so finally now we can say this is absolute value of f of x minus L is less than epsilon. So that means we proved it. All right, so that's how we can prove this this thing using the definition of limit, or precise definition of limit. Okay. Now let's go to the precise definition of infinite limit. All right, so the reason we say this infinite limit is when you take the limit, I get the infinite term here. All right, so for this one, the definition is slightly different to what is it? This one here. Here we got some value L, so that means that there is some value. The L is not infinity. All right, this is a finite limit. But here, this is infinite limit. All right, so the definition here is slightly different. So, okay, so here what we're going to see here is, let's say if we have something like this, and this is a point A. Let's say this graph is f of x graph. So when x approaches towards A in the function f of x, then the limit of this is, you can see that on both sides from left and right is approaching towards positive infinity, right? So that's exactly what it's saying. This graph is the representation of this. Now, the definition, the way we write the definition is similar to what I did before. So again, now it's going to be for every positive number m. All right, so positive number m, there is a positive number delta such that now if 0 is greater than x minus a is less than delta, then here we should get f of x is greater than m. So like I said, the m should be up any positive number. Basically, m is anything greater than 0. So m should be on y-axis. So m can be anything on y-axis. So that means our f of x should be anything greater than m, means f of x also should be greater than 0. That can be anything going towards infinity. So anything that is going towards infinity, if x approaches towards a, then we get, yeah, m, and f of x is going to be greater than m. All right, so now let's try to do something. Let's try to do an example, something related with this. All right, so let's do this one now. Now here we have this infinity, right? This is similar to this. Let me just write that here again. All right, so that means here I can say that a is 0. This thing is 1 over x squared is f of x. And start from scratch work. All right, so scratch work, our definition says, the actual definition here is this one. We need to use this definition. All right, so if x minus a is less than delta, then f of x should be greater than m. All right, so that means again we are proving f of x is greater than m from this. But in the scratch work, we're going opposite direction, right? So we are going from this to this, this to this to get the delta. It's just that the definition here is slightly different. Here we have f of x greater than m. The previous one, there was absolute value of f of x minus L is less than absolute, right? So understand the difference. All right, so the only time we will use this is if we have limit, or if you're proving the limit goes to infinity. Okay, in that case we are using this definition. Okay, now from here to here, starting from this, f of x is greater than m. F of x, like I said, it's 1 over x squared is greater than m. We don't know that. But from here, we know that x minus a0 is less than delta, or absolute value of x is less than delta. All right. We need that later on. Okay, so now from here, okay, now let's cross multiply, or let's just bring this m down here, x over there. Basically, this is just a cross multiplication, right? And then after this, let's just take the square root on both sides, or instead of writing this, let's just write it like is x squared is less than 1 over m. Okay, now let's take the square root on both sides. X is less than, well, when you're taking the square root, we need to include plus minus, right? But in this case, we're just gonna take plus, all right? So 1 over, or the square root of 1 over m. Or since we're just taking a positive, so the absolute value, well, we are always going to get a positive number, right? So I can just simply say the absolute value is less than positive, positive 1 over m. Okay, now after this, from this one, from this delta equation, I got this absolute value of x minus delta. From this m equation, I got this, right? So comparing these two, again, I have absolute value of x, absolute value of x, less than, so this delta here, now our delta is going to be square root of 1 over m. Okay, this is a scratch work. All right, so like I said, again, you have to show your scratch work in a systematic order. All right, now after this, we haven't proved yet, so the actual proof is again, the proof is going to start from assuming let delta, well, we got the delta value, right? So this is absolute, sorry, the square root of 1 over m. Okay, now after this, we are, the actual proof is from this to this, right? From this point to this point. So from here, basically, we're just going the opposite direction of our opposite work of this. Okay, then if x minus a is less than delta, or x minus a is just 0, so x minus a is just x, or absolute value of x. So this is less than delta, we just say there 1 over m, the square root of 1 over m. Now let's take okay, now let's take square on both sides, right? Square this, square of this is less than, if I take square, the square is gone, so I'll just get 1 over m, right? So the square of the absolute value, we can just say this is x squared, so less than 1 over m. So here I got, now again, cross multiply this, so m is less than 1 over x squared. So again, this is 1 over x squared is f of x, right? That's exactly what I said here. This f of x is 1 over x squared. And we're trying to prove f of x is greater than m. All right, so from here to here. So that's exactly, I got from here, I got here, right? So I got f of x is greater than m. So that means it's proved. All right, so this is the way of proving. So I think I did like three examples. So pretty much on all of these examples, the idea was pretty similar, right? So this last example dealt with infinity. So this infinity definition is this. And here, the other two examples deal with this. So that definition is this. Okay. All right, so that's it for this section. Like I said in the beginning of this lecture, this section is very important. If you have any questions, yeah, feel free to ask me during the office hour. My office hour is, again, I think I've sent out the email about this. My office hour is only Monday and Thursday. All right, Tuesday is not my office hour. It's only Monday and Thursday. Even though the Tuesday is a regular pastime, but I don't have office hour on that day. Okay, so if you have any questions, you can again ask me during the office hour, and that's it for this section. All right. Yeah. Thank you.